right, my beauties, we are looking at page 1 of the empirical rule and z-scores. So the empirical rule is used when our data follows approximately a normal curve. And lots of things in real life follow the normal curve. Heights of people usually follow the normal curve. Weights of newborn babies, of puppies, of almost anything, natural like that. So a lot of measurements, heights and weights and distances, and sometimes scores on tests, but a lot of times not. But a lot of those different things follow a normal curve. Okay, and the normal curve looks like this up here, where it's that bell-shaped curve where it trails off at the end, but most of the data is right in the middle. And very middle is your mean. So this is our mean right in the middle. And we measure on a normal curve using what's called a standard deviation. So the majority of people or objects or dogs or whatever we're talking about are within one standard deviation of the mean. Okay, then it goes out to 2 standard deviations, 3 standard deviations above, or 2 standard deviations below, or 3 standard deviations below. So in this area, 34 and 34%. So basically 68% of the population is within 1 standard deviation of the mean. The little next section, 13.5% is between 1 and 2 above, and 13.5% is between 1 and 2 standard deviations below. Then we get 2.35% and 0.15%. Notice 0.15%. If we wrote that without the percent sign, that would be 0.0015. Okay, so really, really tiny number. So very few people, objects, dogs, trees, whatever, are out here. So this is, when we're talking IQs, this is like Einstein way out here. Actually, I don't even know if Einstein's that far out. All right, so our example, IQs are approximately normal. They have a mean of 100 and a standard deviation of 15. That's old data. I don't know if that's true anymore, but that's how it used to be. Okay, so labeling the curve, that means 100 goes in the middle. Standard deviation of 15, I just add 15. So 115, 130, 145. The other direction, I subtract 15. 85, 70, 55. And the percentages, I'm just going to write those in. So now I'm going to use this curve to answer the questions. So approximately what percent of people have an IQ between 70 and 115? So that would be this area right here. So I'm just going to add those 3 numbers together, and about 81.5% of the population. Okay. What is the probability of having an IQ greater than 130? That should be or less than 85. You can't have both. It's either one or the other. So greater than 130 or less than 85. So I'm just going to add those 5 numbers up together, and that would be 18.5% of the population. Because it's not very likely to be out here at the ends. Very few people are. Okay. 68% of the population have IQs between what and what? Well, when we're doing a between, we're usually saying centered right here in the middle. So 34 plus 34 is 68%, so between 85 and 115. So right there. All right, so 2.5% of the population have IQs greater than what? So I'm going to go to the end, and I'm going to figure out what adds up to 2.5, and it's those 2 numbers right there add up to 2.5. So that means 2.5% have IQs greater than 130. So a very, very small proportion of the population. All right, so that's page 1. Moving on to page 2.